Welcome to the section 4.4 video, which covers proving triangles congruent by SAS and HL. So you should be on page 17 in your packet. We're going to first determine if triangles are congruent, and then we're actually going to prove them congruent. So before we learned SSS, two triangles are congruent if all three pairs of corresponding sides are congruent. Today we're going to add two more theorems. The first one is SAS, side angle side. So this postulate says that two triangles are congruent if two pairs of corresponding sides are congruent and the included angles. So included angles just means it has to be the angle in between the two sides. So if I draw myself two triangles, okay, it says these triangles are congruent if two pairs of corresponding sides are congruent. So here would be one pair, here would be the other pair, and then the included angles are the angles in between those two sides, which means these angles right here. If it was any other angles, it would not be SAS. It has to be the angle in between the two sides. So let's look at example 1. It says determine whether triangle ABD is congruent to triangle CDB. Okay, so right now I have one pair of congruent sides, AB and DC. I have one pair of angles. I also have this other pair of sides. So the side in the middle, that's within both triangles. So now I have SAS, it's the angle in the middle. And let's just make sure that we have the correct congruency statement. Is AB congruent to CD? Well, AB, CD, yep. Is BD congruent to DB? Yeah, it's the same segment. And then AD and CB. AD and CB. So we would say, yes, these triangles are congruent by SAS. Okay, so let's move on. Okay, so example 2, again, determine whether they are congruent. In this case, we have this side ZX that's within both triangles. Okay, and then I have one side congruent to another side, and I have a right angle, and I have another right angle. Okay, so technically I have two pairs of sides and an angle, but the angle is not the included angle. It's not the angle in between the two sides, especially in the case of this left triangle here. That right angle is not in between the two sides. So we would say no. And then for explaining the reasoning, I'm going to say it's not the included angle. So right now, pause the video and try example 3 on your own, please. Okay, example 3, you should have noticed we have this side BD that's contained within both triangles. Okay, so right now I have two pairs of sides and I have a pair of angles, but the angles are not in between the two sides. So again, we would say no, these triangles are not necessarily congruent. We cannot prove them congruent. So hopefully you got that one right. Now we're going to move on to the next theorem. So if you could flip the page. Okay, now we're going to talk about HL, the hypotenuse leg congruence theorem. Okay, well, let's think about when do the terms hypotenuse and leg apply? Well, they apply when we have a right triangle. So this theorem says that two right triangles are congruent if their hypotenuses and one pair of legs are congruent. Okay, so this only applies to right triangles. Okay, so if their hypotenuses, remember that the hypotenuses are across from the right angles, and then one pair of legs. The legs are the sides that are not the hypotenuses. So in this case, these two triangles are congruent. One thing to be careful of is just because a triangle is right does not mean that you're going to be using HL. Most of the time you're going to be, but not every right triangle is going to use HL. Okay, so now we're moving on to some proofs. Let's look at example 4. I'm going to start by writing the givens. So the first statement is AB is congruent to BD, and I'm going to mark that. AB is congruent to BD. And that's a given. And then I have BC bisects angle ABD. Okay, so I have to remember, what does it mean to bisect? Well, bisect means to cut an object into two congruent parts. So if angle ABD is bisected, that means these two little angles are going to be congruent. So angle ABC is going to be congruent to angle CBD. And that's just definition of bisect. A bisect cuts an object into two congruent parts. So right now I have an S here, I have an A here. So I have one pair of sides, I have one pair of angles. And then I notice that both triangles share this side BC. So I'm going to have BC is congruent to BC. That's the reflexive property. So remember, you have to think about when you wake up in the morning and you look at yourself in the mirror, you're congruent to yourself. Any object is congruent to itself. That's a reflexive property. Okay, now I see that I have SAS. I have two sides and the included angles. So I can go right to triangle ABC is congruent to triangle DBC by SAS. One thing to notice is that your steps will not always come in the correct order. So we could have had SSA here, but you really have to look at the figure to know what theorem it is, because our steps could sometimes go in different orders. Okay, so now let's move on to example 5. Okay, so my first statement, I know that NO is perpendicular to OQ, and I also know that OQ is perpendicular to QP. That's a given. Okay, perpendicular means that we have right angles, which is shown in the figure, but we still need to say that. So angles NOQ and PQO are right. If we remember from before, that's the definition of perpendicular. Remember, one statement generally becomes the next reason. Okay, I'm not really sure where that's going to go. So let me kind of look forward. The next given we have is that NQ is congruent to OP, which is a given. Sorry, this should be an O, not a Q. Okay, so that's what I have right here. So if I notice, I have a right triangle, and I have the hypotenuse. So that makes me think that I might be using HL. So because of that, I have to say that I have a right triangle, because HL, hypotenuse leg, only applies to right triangles. Well, I have right angles, which then means I have right triangles. So I can say triangle NOQ and triangle PQO are right. For a reason, I'm just going to say right triangles have right angles. Or you could have put in definition of right triangle. Okay, so I have the H part right now. So these two sides gave me the H. Now I need the L. I need a pair of legs that are congruent. Well, if I erase this so we can see a little better, both of our triangles share this OQ side. So then I'm going to say that OQ is congruent to OQ. That's the reflexive property. And there's my L. Okay, so I said I had right triangles, then I did the H and the L. So now I can say triangle ONQ is congruent to QPO by HL. So it's okay if you're a little confused. We'll do some more of this when you come to class. We have one more that we're going to do together, and then you have one to do on your own. So if you could please flip to page 19. Okay, this is example 6, and then you have an extra example. So first given, FG is congruent to EH given. Okay, so I'm going to mark that FG is congruent to EH. Then I have that FG is parallel to EH. So that's that. Okay, anytime we are given parallel lines, it's for a reason. We should be able to gather some piece of information from these parallel lines. I told you all, when you have parallel lines, always look for the Z. Because within the Z, you're going to have congruent angles. So here I can say angle FGE is congruent to HEG. Okay, so GE is my transversal. These are on opposite sides of the transversal, and they're interior angles. So my reason is, if I have parallel lines, then the alternate interior angles are congruent. That's something we've done before. Okay, so right now I have an S and I have an A. I need to find another pair of sides. I don't have any right angles, so I can't use HL. If I notice, both triangles have this side GE. So then I'm going to say that GE is congruent to GE. This is the reflexive property. Okay, again, this is my other S. Now I'm done. I can say triangle EFH is congruent to triangle GHE by SAS. And that's it. Okay, so looking forward, we did two things today. First, we determined if triangles were congruent, and then we actually proved them congruent. I would like you to try this extra example. I'm going to give you a clue that this involves HL. So you're going to want to look specifically at example number 5 when you were doing this. Good luck. When you come to class tomorrow, you will only get full credit if you have this proof completed. Please bring any questions you have to class. Bye.